Now, dear students, we already discussed about work energy theorem. But when we discussed about work energy theorem, we considered force as a constant quantity. But then we discussed it is not necessary force is always a constant quantity. So if the force is a variable force, then how to calculate work done? That we already discussed. Now, if force is a variable, then how we can represent the work energy theorem? Okay. So now we have to discuss the work energy theorem for a variable force. Okay. Now suppose force F is acting on the object having mass M. Okay. And this particular force is a function of X, means it is a variable force. So we can write the work done W, that is integration Fx dx initial to final position, right? Now F, force that is mass into acceleration, and acceleration that is equal to rate of change of velocity, acceleration A, that is dv by dt. So we can write force that is mass into dv by dt, that is acceleration. Now this dv by dt dx, that we can write dv into dx by dt also. So m dv dx by dt. Clear? Now dx by dt, rate of change of position, that is the velocity. So we can write dx by dt, that is v. So m is a constant quantity, take it outside the integration. So dx by dt, that is v, and this one is dv. Okay. Now suppose at initial position the velocity is vi, and at final position the velocity is vf. Then we can write this integration as w equal to m integration vi to vf v dv. Now here v, that is v raised to 1. So if we integrate it, then we will get the integration, that is v square by 2. So here we can write m into v square by 2, lower limit is vi, upper limit is vf. Now substitute the limits. So first v, that is vf upper limit, then minus v, that is vi lower limit. So we can write m by 2 into vf square minus vi square. So after all, we can write w, that is half vf m vf square minus m half m vi square. Half m vf square, that is the final kinetic energy, because this is the final velocity. Half m vi square, that is the initial kinetic energy, that is ki. So resultantly, the work energy theorem for the variable force, that is also the same thing. The net work done by the given force, that is equal to change in kinetic energy, right? So this one is the work energy theorem for variable force as the same form.